Hey guys, today we're going to be talking about volcanoes. So we just wrapped up earthquakes last week and now we're going to move on to volcanoes, which is exciting. So let's start with some questions that are going to be answered in our lesson today. How are volcanoes and plate tectonics related? What causes the difference? And what are those differences between the volcanoes? Because they're not all the same. So a few terms that we should go over before we get into the notes today, and hopefully you've made a copy of the student notes where you can, just like last time, you'll fill in the blanks with the notes from here. I added in this slide though just because it talks a lot about density and temperature and pressure and the effects that it has on rock. So density, if you remember from our physical science units, it's the ratio of mass to volume. So for example, oil and water are different densities, therefore they won't mix. The denser material will sink to the bottom and the less dense material, which is the oil, will float on top. So water just has more mass per unit volume than oil does. And the next thing is temperature and pressure and the effects that they would have on rock. I chose iron as an example because there's a lot of iron in rock, especially magma, which is going to be the focus of our discussion today. So the iron is in solid form, as you can see here, under high pressure and relatively low temperatures, but also some high temperatures. So this line right here represents the border between when iron is solid and when it would be liquid. So very high temperatures and low pressures indicate a liquid rock, and relatively high pressure and lower temperatures will give you a more solid rock. So how does this relate to anything? But if you remember the layers of the earth that we discussed, the inner core, outer core, mantle, upper mantle, right? They're all different states of matter. So this diagram here is showing how as we go further into the core, we are increasing pressure, right? Because we have lots of layers on top, so it's really increasing the pressure, really pushing that rock together. So that's going to cause us to have a more solid rock under very high pressure, as we can see here. And as we move out, right, like in our upper mantle, that is in the asthenosphere, right, that is a liquid, right, because we have less pressure, right? So the less pressure we have down here, even though it's relatively hot still, we're going to be in a liquid form, right? And that liquid allows our plates to move. If you remember, our plates in the crust. So the crust is a solid because there's very little pressure here. So very little pressure and relatively low temperature as well when we get to the crust. So high pressure, high temperature in the inner core, low pressure and temperature in the outer crust here. So, where do we find volcanoes? Where do they form? If you remember the Ring of Fire, that is a hotspot for volcanoes because of the plate tectonics that is happening there, right? So plates are moving, and that's going to create a lot of volcanoes in that area. We'll talk a little bit more about that later. So just a real quick recap on the difference between magma and lava. Magma is considered to be inside the earth, right? So it's the molten rock that's stored in the earth's crust. Once it erupts from a volcano and starts to flow down, that's when we consider it to be lava. So the word lava actually means like to flow. So that's kind of where that came from. So magma is formed when you increase temperature, when you decrease pressure, and then if you add water. These are all processes that allow magma to form. So magma meaning liquid rock. So this diagram is showing that, right? Increasing pressure, increasing temperature, decreasing the pressure. That's going to give us liquid. The opposite will give us a solid magma, solid rock. right? So if we decrease the temperature or if we increase the pressure or take water out, that's going to give us the solid state here, which we would call igneous rock, and we'll learn more about that later. So magma can form in 3 different ways, in spreading centers, so divergent plate boundaries, in mantle plumes, and in subduction zones. So remember, subduction is when one denser plate moves underneath a light or less dense plate. So the first one is the spreading centers. So as lithospheric plates separate, so as the crust separates in the ocean floor, the hot plastic, so plastic meaning liquid rock, asthenosphere, is going to ooze upwards. So the plates move, and then the rock comes in and fills that gap there that's left behind from the seafloor spreading apart. As it comes to the top, it's going to have a decrease in pressure because it's coming farther and farther from the intense pressure inside the earth, and that's going to allow it to form this basaltic magma as that pressure drops and that melting occurs. So magma has a lower density than surrounding rock, so it rises towards the surface. Just like in the liquid and the water, or the water and oil example, if you were to shake that up, the oil is always going to rise to the top. You might see that in your salad dressing because it's less dense. And this occurs underwater at the ridges. So remember, when the divergent plate boundary occurs, that center where that magma comes up and cools, that is called a ridge. And you can see that right here. So we have the plates diverging, magma comes up and cools, and here's our mid-ocean ridge. So the second type of magma formation is in a mantle plume, which is a rising column of hot plastic or liquid rock that originates deep within the mantle. Plume rises because it's hotter than the surrounding mantle and is less dense. So if you think of like a hot air balloon, right, heat rises. As the plume rises, pressure releases and melting forms magma, which rises to the surface. So this can be seen in hotspots. So a hotspot, we talked about this in our last unit, is how the Hawaiian Islands were formed. So basically you have a really hot spot in the mantle that has this rising plume of magma, and as that plume keeps erupting and the magma keeps coming out, the plate is moving on top of it. And you can kind of see that happening in this picture here. So the magma is coming up, the plates are moving, and it just stays in this one spot. So these were volcanoes that were once active, but as that plate moves, right, the new hot spot is right here, and the next hot spot is going to be right here. And so we have this chain of islands forming, and that's how we got the Hawaiian Islands. So if it rises beneath the sea, the volcanic eruptions build these submarine volcanoes and thus the volcanic islands. So submarine just means that it's underneath the water, right? So this is the ocean, right? So they're underneath the ocean, and they build over time, so that we have an island that we can live on, or lucky people can live on. So the last one is a subduction zone. So magma can be produced when 2 plates come together, and then the more dense plate subducts underneath, right? As that dense plate sinks below the less dense plate, it starts to melt, right? Because it's increasing temperature and it's increasing pressure as it goes down, down, down inside the earth. And this is what's happening at that ring of fire. That's happening on our Pacific coast, and then over in Asia, that creates the rest of that ring of fire. That's all due to a subduction zone. So we have dense oceanic crust sinking below less dense continental crust. And that's how about 75% of our active volcanoes are actually formed, is that subduction happening. So you can see this a little bit better than just my hands in this nice diagram here. So dense oceanic crust subducts underneath. As it does, it melts. And so then we get that rising magma from that melted rock, and here it forms those volcanoes, right? So this would be an example of like what the Ring of Fire actually looks like, right? It's literally like a chain of volcanoes on the edges of our continents, right? So if you remember, right, it creates that chain all along California, down in South America, right, and then over in Asia here. And that was our Ring of Fire. So that's all that we have today. We're going to finish up these notes tomorrow. We're going to have a short exit slip. Make sure you take that 5-question multiple choice quiz on Schoology, and then we'll finish the notes tomorrow and wrap up the volcano terms. I hope you guys have a great day, and I'll talk to you soon.